Hello, Wayland Middle Schools. Mr. Farley here for another exciting video. This time we're going to be looking at evaluating functions on a graph. So let's get going here. You know you've started to learn about function notation, where we have this notation right here known as f of x. That's the way we say it. Just as a reminder, the x here in parentheses is just the input. So we're going to be putting something into a function, and then it's going to give us an output. And that's what this is telling us right here. We are looking at this notation, f of x equals 1. This means we are looking for a location on this graph where the output is 1. Let's remember, output is the y-axis. So I look here on the y-axis and I look for a value of 1, which happens to be right here. So our job now is to find what value of x will give us this output right here. And the way we can look at it is look at the x-axis now, and I think if we input -1, which is right here, it will touch this green graph right here at 1. So you'll see that if x is -1, the output on the y is 1. That's what this notation means. It's trying to say what input will give us an output of 1, and in this case, x is -1. Let's try this one. This notation means it's the f of x equals 2, meaning I need an output of 2. So when I look at this graph, right here on the y-axis, I see an output of 2 right here, and I also see an output of 2 over here. So we can look at it and now answer the question. Give us the value of x that will give us the output of 2. Well, it looks like when x is 0, there is an output of 2. There also looks like when x is 8, there is an output of 2. So in this case, we have two different locations, two different inputs, an input of 0 and an input of 8 that will give us outputs of 2 on this graph. Okay, I'm going to clear this for just a minute, and let's try the next one. The next one here says f of x is 8. Again, where on this graph is there an output of 8? So I need to go to the y-axis. Y happens to be our output. 8 is way up here, and I'm looking to see, is there anywhere on this green graph that has an output of 8? And if we look closely, we'll see, no, there is not. So we can just say here, does not exist. Okay, so you can say something like that, does not exist. So there is not a value of x that will make this have an output of 8. Let's try one more that's not shown here, and that one's going to be, let's say, f of x. I'm going to make it up right now. You can write it down in your notes. F of x equals 6. Well, we're looking for the location on this graph that has an output of 6. Go to the y-axis. Look for 6. Okay, here's 6. Now let's see, does the green graph touch 6 at any time? Yep, touches it here, and it touches it here. This one has 3 different locations. So when I write this, I would say, oh, at 4, when x is 4, there's an output of 6. So we can say x equals 4. Wait a minute, there's another spot. X is 6. When x is 6, y is also 6. So now we have 2 spots that this happens. And if we look very closely, there's a third spot, and that's when x is 9. We can put a 9 right there. 9, it will happen. So these are different spots. Three different cases, and an input of 4, 6, and 9 will give us outputs of 6 on this graph. So these are pretty good. This is the way that we evaluate functions on a graph, and we also can do it algebraically, which I will show you right here how to do that. All right, so to do this algebraically, we can click, give me one second. Ooh, sorry. Let's do this here. I'm going to switch over to the second slide. Everyone has this this one right here, finding inputs given outputs right here. So if you give me one more second just to get the right, there we go. All right, so let's continue taking notes from this slide here. Everyone has that paper in front of them. So listen carefully and take careful notes. This time, this is all algebraic. We will not have a graph given to us. So what we're looking here is at a function. The function is f of x equals 2x plus 5. We want to find out where the f of x is going to equal 10. So that means where will this function have an output of 10? So what we do is we take this 10, okay, and we're going to plug it right into the f of x, because this is the output. It's telling us the f of x equals 10. I'm going to plug it in. If you look right over here, I did this for you already. I made f of x equal 10, so 10 equals 2x plus 5. Let's solve it. Everyone knows. Subtracting 5 from both sides, I get 2x is equal to 5. I'm going to divide by 2. And x is equal to 2.5. 5 over 2 is 2.5. So if you went to a graph and you inputted 2.5, if that's your input, the output would be 10. And we're doing this just algebraically. Let's try this one here, which is a little bit harder. We have not solved a square in a little bit. Let's give this a try. So this is the function. It's called the g of x. The g of x is equal to x squared minus 4. I tell you, g of x equals 21. That means I can take 21 and substitute it in for the g of x. And if we come right over here, I did that for you. 21 equals x squared minus 4. You can see I took what I had before over here and just substituted in the 21. Now, let's add 4 to both sides. We can do that. We've been doing this for a while. We get 25 is equal to x squared. We need to solve this equation. In order to solve a square, to undo a square, we need to square root. And if we square root 25, I'm hoping we are going to get 5. But also remember, if you square root 25, we have positive 5 and negative 5. So make sure you tell me x can be positive 5 or negative 5, all right? So positive and negative. Last one, h of x, a third function is given to us. That is equal to negative 3x plus 7. I tell you, and this is a mistake, this should not be f of x here, so on your notes, could you cross that off? Make that the h of x, all right? I tell you h of x is equal to 16. That means I can substitute 16 right into this equation here. So now I have 16 equals negative 3x plus 7. To solve it, I can subtract 7 from both sides. Negative 3x is equal to 9, dividing by negative 3. And I find out that x is equal to 9 divided by negative 3 is negative 3. So if I have an input of negative 3, my output will be 16. So here are three different examples for you to take a look at. Make sure you've taken notes on everything we've talked about in this video. And I will be back next class so that we can fill in any questions that you might have. But this definitely will get you started. Hope you enjoyed the video and look forward to seeing everyone in class tomorrow. Take care.